Hello everybody. Let's look at the idea of a limit, which is the key base of the calculus course. What does it mean for a function f(x) to have a limit L as x approaches c? The number L is a solution of the limit function as x approaches c, and the c is the number that the x gets arbitrarily close to but not equals to. Let's look at the examples to understand the limit idea better. The first example asks you to find the value L for the limit function x plus 1 as x approaches 1. Let's pick a random point on the function and say it is a x comma y. And find out what is the limit of the function value L as x approaches 1. I picked a random point x here, which is on the left side of x equals to 1 on the graph, where both x and y values are negative. As x approaches 1, the y value increases, and as it gets close to 1 indefinitely, what would be the y value or L value of the limit function? It gets close to 2. So the limit of the function x plus 1 as x approaches 1 from the left side, it has L value 2. And what if it picked a point x comma y that is on the right side of x equals to 1 value? In this case, it starts from a y value that is bigger than 2, and as it gets closer to 1 indefinitely again, then the limit of the function value becomes 2. So limit of the function x plus 1 as x approaches 1 from the right side, the L value again is 2. Note that for the limit functions to be defined, the left and right arbitrary value must be the same. What if we don't have a graph given to us and asked to find the limit function value? Then we need to make a table to see the changes in L values as x approaches to 1. Let's look at the table to verify the answer we got from the graph analysis. Here's the table, and the first row gives x values, and the second row is the function value of x plus 1. As x approaches 1 from the left side, the function value y gets closer and closer to 2, and the limit of the function value becomes 2. This pattern stays the same when x moves from the right side, and limit of the function value as x approaches 1 from the right side is 2 as well. This verifies that the limit of the function value is 2. Let me ask you a quick question. What is the function value when x equals to 1 without the limit notation? So fx, that is equals to x plus 1, and when x equals to 1, the function value is 1 plus 1, which is equals to 2. It seems like the limit value and the function value are the same in this question, and why do we need a limit function when they are the same? This is one example question that we can find the difference in the limit value and the function value. The function gx is given, and it is x squared minus 1 over x minus 1. This is a rational function, and we have restriction on the x value where it makes the denominator 0. When x equals 1, denominator value gets 0, and for the function gx to be defined, x cannot be 1. Let's simplify the gx function with popular binomial formula x squared minus 1 over x minus 1, which is the gx function. That is x plus 1, x minus 1 over x minus 1. And you can cancel x minus 1's here, and it gets simplified to x plus 1. This is the same equation as the fx function it does not define at x equals to 1. If you recall the definition of the limit of the function value is an arbitrary value when x approaches 1, not the value at x equals 1. So we can use both graph analysis and table method to find the limit value, just like previous example. You can choose a random point from either left or right side of the point, x equals 1, and no matter which point you pick, the y value gets closer and closer to 2, and they both have limit of the function gx values of 2. You can again verify the limit of the gx from the table as well. So the limit value of the function x squared minus 1 over x minus 1 as x approaches to 1 is equals to 2, and the function value when x equals to 1 is undefined. This is the case where you see the limit value here, and then the function values are different. The key thing to remember from this video is that the left and right limit value must be the same for limit functions to be defined. Thank you very much, and have a nice day.